So this is a Blender recreation of the Dickinson quad, and this is our AI drone going along the pathways. As you can see, it's a snowy day at Binghamton. So there are ice patches on the pathways, and so it's ready for its snow and ice removal procedures. So if it's not in training mode, it would be like max amount of steps, which would play forever. This is when the episode begins. So one episode is one generation of those ice patches and the drones going to collect them. And we have these functions, and then we have the moving to a safe random position at the once it gets one of the ice patches. Move to safe random position ensures that it doesn't spawn in the wall or in any trees or anything, so we make sure not to make it an infinite loop, and we pick a random ice patch. So this is accessing our list of ice patches and the full length, and then from that we position 10 to 20 centimeters, as it says, in front of the ice patch, and then we pick our potential position. Or it calculates our potential position this way. Then we have this to see if it'll collide with anything specifically, because that's what we're trying to avoid. And finally, it sets our position and rotation for moving to a safe random position. When we go onwards, we are updating the nearest ice patch because we are trying to calculate the distance between the nearest ice patch from the drone. And so here's how we calculate this. Moving on, we go to on actions received. So in reinforcement learning, an agent has several actions it can take, and so this is its action space. It's also a concept in Markov decision processes, which are basically what reinforcement learning is about. And so we are adding all the potential actions that it can take, and making sure that the changes are smooth, because we were kind of dealing with some jittery movement before. Second, we have collect observations. This is another important part of machine learning, reinforcement learning, where the agent has to collect observations about its environment. So we have 9 different observations, things like its own local rotation, vector from the drone to the nearest collider, and specifically this is a dot product that has a vector facing from the drone and then a vector facing from the ice patch, and our hope is this would be 0 because when the drone is right above the ice patch. And so then we move on to heuristic, which is basically the player input to manually use the controls for this. When we want to go into player mode, this is especially important. And these are some other functions that are used in play mode. And then this is when we collide with an ice patch. It attempts to, this is where we use our salt method, and it is where in training mode we add rewards, which is the third integral part of reinforcement learning, to add rewards for certain actions. And so that sums up most of the program. So yeah, that